Hello and welcome. I hope you remember when we discussed the different families of functions or all the parent functions, and we talked about each and every graph, their unique shapes, and also their unique features as well, domain range, intervals of increase, decrease, etc., etc. So this time our attention will be focused on how a point is transformed in a parent function. Suppose that y equals f of x is the equation of, or represents the equation of any parent function. We are going to take a look at what's going to happen to a point on the graph of y equals f of x. And the point can be indicated by the coordinates x, f of x, when the function has undergone such transformations. Remember, the transformations are caused by the following coefficients: coefficient A, K, D, and C. So what we are going to do is take a look at each and every coefficient and see how each coefficient will change the coordinates of a point on the parent function. Remember, it doesn't matter which parent function we are looking at, as long as we know the coefficients, and we'll be able to determine what the coordinates of the new point will be. Usually we refer to this as the point on the parent, and the new point is the image point, the point after the transformation. So the first transformation is y equals a f of x. That's a transformation caused by multiplying f of x by coefficient a. Remember that f of x represents the coordinate y, so the vertical coordinate, and when y is multiplied by a coefficient a, that means that the function has undergone vertical stretch. So I'm going to leave it for now as vertical stretch. And we're going to say that this vertical stretch will be an expansion if a is bigger than 1 and less than -1. And a will be represent a vertical compression if a is bigger than -1 and less than 1, again providing that a is always different than 0. Now, if a point with coordinates x and y is in the graph of the parent function, the new coordinate or the transform coordinate will be x, a, y. Now, why is that? Remember that the coefficient a is before or is multiplying f of x, and f of x is another name for y, which means that for the same input value of x, the y coordinate will become a times y. So the only change, or the change in the transformation, is reflected only on the y coordinate. So for example, if we have the function y equals f of x with a point with coordinates 2 and 7 on the graph of y equals f of x, if we transform the function to become -3f of x, it means that the new image point will be x equals 2 and y will be -21. And how do we get -21? You multiply 7 by -3. Okay? The next transformation is the one that is caused by the coefficient k. Remember, coefficient k is the coefficient of x. What that means is that the x variable will be affected by it. So k causes a horizontal stretch. Now, the horizontal stretch will be in the form of a horizontal expansion if k is between 1 and -1, or it would be a horizontal compression if the value of k is bigger than 1 and less than -1. Remember, k also has to be different than 0. So What we are going to say in this case is that the new point in here is not going to change the y value. The y value will stay the same, but the y value will be reached for different values of x. So if k is, let's say, for example, bigger than 1, the values of x that are needed for the y will be k times smaller, okay, because they are empowered by k. So we're going to say that the coordinate of x for the new point will be x divided by k. So here is an example. If we have y equals f of x, and in y equals f of x, we have a point with coordinates 2 and 7. And we have transformed f of x to make it f of 3x. That means that the new point will have the coordinates. X will be 2 divided by 3, and the value of y this time will stay the same, so 7. The next transformation is the one caused by coefficient d. The coefficient d will cause a horizontal translation. I'm going to go orange this time. So the horizontal translation can be in the right or left direction. And we're going to say that if d is positive, it's going to move to the right. So d positive, it's going to move to the right, and d negative will move the graph to the left. Okay, and d is equals 0 won't move the graph at all. Now remember that the coefficient d is directly cooperating here, or working with the x variable. So the variable x is subtracted a number. We're going to say then that the variable x is the one that is changing, the y will stay the same, and x will be increased by whatever translation we have applied to it. So x plus d and y. So for example, if we have a function y equals f of x, and we have transformed it to become y f of x minus 4, then we're going to say that the value of d is positive 4. So a point with coordinates 2 and 7, this time will become x equals 2 plus 4, or 6 and 7. So only the x coordinate is changing. The last transformation is the one caused by the coefficient c. So the coefficient c is the one that will affect the vertical coordinates. So we have an addition of c units to the vertical coordinates, and we're going to say that it causes a vertical translation. Okay, and if d is negative, the translation will be, c is negative, the translation will be down. And if c is positive, then the translation will be up. And when c is 0, there will be no translation. So in this case, the coordinate x will stay the same, but the coordinate y will be increased by c units. So if we have a function of the form y equals f of x, a parent function, with a point 2 and 7 in on the graph of f of x, then we transform this function according to the equation y equals f of x plus f of x plus 3. Then we'll say that the x coordinate will stay 2. The y coordinate will become, in this case, 10. Okay, so let me just change this very quickly. And we have 2, and 7 plus 3 will equal 10. Now, this is what happens when we apply each transformation separately. What if we apply the transformations all in one step? So the point with coordinates x and y in this case would be, okay, give me 1 second, and I am going to give us a little bit more room to complete this. Okay, so we are going to say that the point will change to become from x, y to, remember that x is affected by the coefficient k, so x over k plus d, and the y coordinate will be ay plus c. Now, as an example, I am going to take a function y equals f of x. Let me choose a unique color here. It's kind of hard because we kind of used up all of them, but here we go. So if we have y equals f of x with a point with coordinates 2 and 7, and we have applied the transformation y equals negative 3 f of 2x plus 1 minus 4. Okay, so we're going to say that a is negative 3 and k is 2, d is negative 1, and c is negative 4. So the new point will be x, which was 2, divided by k, which is also 2, plus d, which is plus negative 1, and the y coordinate will be negative 3, which is a, times y, which is 7, plus c, which is negative 4. So if you calculate each coordinate, sorry, I'm going to highlight them so we can see more clearly which one is x and y, which one is y. So that's the x, and this is the y coordinate. We're going to say that 2 divided by 2 is 1, plus negative 1 is 0. And the y coordinate is negative 21 minus 4, negative 25. And that would be the new image point. So that was it and for today, and I hope this made sense. Write me any comments or any questions that you have.